Then we came out with a final proof of concept called Byte. So with Byte, we are transmitting data over sound. So there's data being transmitted over a very there's data being transmitted over a sound wave. So let me just continue. So what exactly is Byte? So in its current form, Byte transmits data from Byte transmit text, specifically text, from one device to another using sound. So how does this actually work? So first, Byte gets the text, it converts the text into an audio file, and then sends the text to another device. So at the other device, so it gets the text and decodes the text back into a sound wave. Sorry, back into text. So it gets the audio, decodes the audio back into text. So yes, that's what Byte does. So this is a very quick demonstration of Byte. So over here, I'm transmitting data from my phone to my laptop using Bytes. Um, Trigger warning: this might get a bit irritating, so just get ready. I hope the sound isn't that loud. Okay, so the text I'm sending here is hi there, and then when I send it, it makes this irritating noise, and then my laptop receives the text from just that sound. Is that it? Okay, good. So in order to understand how bytes works, we need to understand how sound works. And then, sound has a lot of properties. So sound has amplitude, sound has overtones, sound has harmonics. But in order to understand the scope of byte, we need to understand how the frequency property of byte works. Okay, so what exactly is frequency in the first place? Okay, so frequency in its simplest form is just the pitch of sound. So how high or low the sound is. So more technically, you can say frequency is the number of oscillations, the number of sound oscillations per second. Okay, so the diagram, oh, not the next slide, sorry. Okay, so the diagram here is just an illustration of sound moving from a really low pitch to a really high pitch. That's what is over here. So I will demonstrate that in this audio, if only the audio works for me. So I don't know, you can. This kind of system using frequency is not something new. It's called frequency modulation. So frequency modulation, as I'm sure all of you have heard of it before, is just FM. So 99.7 FM. So 99.7 frequency modulation. So that's exactly what it is. So imagine you have the number two. How are we going to encode two into a sound wave? Let's keep quiet to think for a while. Okay, so we can say two is very abstract. I mean, what exactly is a two? There's no specific sound wave that represents the number two. So we can simplify two down into a very simple form. So we move to the next one. So we can say if we want to simplify two, we can binarize two, which is just converting the two into binary. So two in binary is 1 0. Okay, so now we're getting somewhere. How do we convert 1 0 into a sound wave? Okay, let's see. Let's see. Let's think. Okay, so we can say that we can convert all the ones to a specific frequency and all the zeros to another frequency. So let's try that. Next slide. Good. So this is how byte works. So every zero in the text is converted to a specific frequency, and every one is converted to another frequency. So there'll be a difference in the frequencies, and then you can decode that as binary. So this is an illustration. I don't know whether those at the back can see it. It's text to ABCD. We convert ABCD to binary, and then we convert the binary to audio. So if I'm with deep learning in Daba when I did this thing. So the message I sent was in Daba, and it went to in Daba over here. And then I meant to type TEDx over here, but autocorrect did me bad, so it's autocorrected it as text. So text is awesome. It was supposed to be TEDx is awesome. So TEDx is awesome. Okay, next slide. Okay, so now we understand what Byte is. Byte is purely a proof of concept, but then it has a bit of potential. So I'm going to give you a brief overview of the potential of Byte and the areas it can be applied to. So next slide. Yeah. Okay, so Byte can be implemented as a QR code alternative. So instead of using a camera to scan, we can just encode the identification token as a small sound wave, very small, maybe less than 1 second, and then send maybe a link or contact information or again a token to another phone. So just like your phone works, let's say you want to call Siri. So hey Siri, this will work the same way. So once it hears the audio, the phone will just automatically detect it and just gets the information at once. Okay, so the next slide. Okay, so at this point, I am in a telecommunication school, so I know how difficult and how confused students get when they're learning data communication. So Bytes can help students understand data communication better. So since Bytes allows you to hear the frequencies, you would understand how the data is moving from one device to the next. So it will help you understand things like frequency shift keying, frequency modulation, demodulation, etc. Next slide. Okay, so the final application, which I think is really cool, is Bytes can be implemented for ultrasound. So instead of hearing a sound when you're sending the message, you can actually just like you can just use silent sound, which is ultrasound. So the message will just be sent from one device to the next without hearing any sound, and that's really cool. Next one. Okay, so my final words. The theme for this TED event is Uncharted. So we are discovering new paths, we are exploring new ideas.